Well, still good morning, everyone. I hope that you are enjoying the conference this second day. And before getting started, I would like to know who's a Fluent Bit user and who's not, so I can get a sense of how to drive the presentation. So please raise your hand if you're using Fluent Bit. OK, it's like 80%. OK, so my name is Eduardo Silva, a creator and maintainer of this project. And the focus of today's presentation is to get you into the weeds of the Fluent ecosystem. And we can get started with that, first talking about the timeline of the project, where we started very early in 2015 with Fluent Bit. Actually, Fluent D is around 14 years old. And Fluent Bit was born just when the CNCF was created, just after Kubernetes was donated from Google to this new foundation. And after time to time, Fluent D has been evolved as a solution in the cloud ecosystem. And Fluent Bit was always kind of the small sibling around that was solving the problems at that area for embedded Linux. But at some point, containers exploded. They demanded more performance. And Fluent Bit was pivoted from embedded Linux to the cloud. But it can work from a really small Raspberry Pi to any type of server. And as of today, after 10 years of the project, actually we have our new character with Fifi and friends that is called Bitsy, with Bit, Z-Y. And I have to announce a little change that we have in the organization. For many years, the organization was always named as a project that was called Fluent D. And Fluent Bit was always under the umbrella of Fluent D. So starting today, the Fluent D organization has been renamed to Fluent. Right? Well, the GitHub organization has always been Fluent. But this is just a CNCF internal change, where now Fluent D and Fluent Bit are both graduated projects at the same level. There's no longer more sub-project. Actually, both belongs to the Fluent organization. And of course, this is a good change after running this for 10 years. And we are celebrating 10 years, right? More than 15 billion downloads, a ton of users, ton of bugs, ton of issues. But we're solving big problems, and that's why drive us here. And thanks for everybody who has trust in this project, since really small contributors, users, up to the hyperscalers. I don't know if you were in the keynote this morning. You were there? OpenAI gave a short keynote about their use case of logging and how do they use Fluent Bit to scale the whole infrastructure and move the logs. But the main use case here is like they found a bug. And the bug was like, hey, Fluent Bit is using so much CPU. Yes, you can imagine how OpenAI infrastructure system could be, right, with all the workload that they have. Now, the biggest thing is like they were looking for ways to reduce the CPU usage of Fluent Bit and actually just turning a configuration key from one parameter to the other, the CPU usage decreased 50%. That was a workaround. Of course, there's a bug, right? However, this is really good because everybody is using this tool, and not because, hey, the logo is cute or cool. It's because it solves a real problem that moving data at scale, it's a challenge. And this project for 10 years has been driven by the same values: high performance, be vendor neutral. That means that fully open source, but also that we integrate with competitors, with private solutions. Hey, we connect with Splunk, we connect with Elastic, we connect with PostgreSQL, all the solutions that you can imagine. And other value that we have is like Fluent Bit has a pluggable architecture. So we have the concept of internal plugins. They're all built in. However, you can extend Fluent Bit to collect sources of data from multiple places or send the data to multiple destinations. And as I said, the biggest problem is like data volume is growing year over year. I think that since everything is getting more expensive year over year, we're generating more data because everybody's creating more systems. So this problem will not go away. What we need to tackle is how to solve this problem in a very smart way that does not mean a higher cost for you, for the user, right? If you're deploying the cloud, if you use more memory, more CPU, of course, you will need to pay more for that. And the whole goal of this, I would like to use this slide, is like users don't wake up in the morning trying to say, oh, I'm going to use my telemetry agent today. No, you just wake up in the morning and you just want to analyze data. Analyze data. But in order to analyze data, you had to deal with this, with a distributed system with logs, metrics, and traces that are everywhere. And the biggest challenge is like this data, right? It's not the same to have the data in 2, 3 servers than 1,000, 2,000. So how do you do your analysis? And the thing is that if you think about Kubernetes, microservices, this gets worse. And our users always demand more performance at a lower cost, right? And that is good. So how do we solve this? To move the data from different sources of information, like applications, firewalls, file system, whatever, to send the data to the places where I can do data analysis. And that are destinations, and this, how do we solve the problem for Fluent Bit for those who are not familiar with it. And Fluent Bit has been around for many, many years. And the way that routing works, routing means how do I take data from a source and I decide to which destination to send it. Actually, Fluent Bit does not decide. The user defines in a very declarative way in a configuration. Everything that comes from this source will go to a different destination. And we do this by setting up what we call rules, like a tag, which is like a label that the input plugins attach in the configuration. So everything that has been processed by a specific input get attached to a tag, and the outputs define a matching rule. And if it matches, it will flow on that way. OK, this is too complex. Maybe we can take a look at this. On the left, we have the weblog applications. Oh, let me see if the new app we're cooking for this is working. OK, so we are here. This is the same thing, app.web. We have defined that is the tag. And if we play out this rule, we will see that the data is flowing to these 2 other output destinations, right? And why? Because we have some matching rules in the output that says app.wildcard, and the OpenTelemetry one says, give me everything. But if we have another input that has a different type of tag, the data will flow in a different way. Now, if you abstract from this concept, you will see that the data flows in a way that the user says, everything that comes from this place will go to that place. But we are in a new era where this is not enough, right? We need to have more context. And this is where Fluent Bit 4.2 that we are launching today comes with an extension to this routing mechanism. And basically, it's a next generation routing mechanism that allows you to define a route based on the content of the data. Before was just from where the data is coming from. But now, if the data contains certain pattern, like this key equals this value, so send it out to Splunk. Maybe you need to query that information really fast. You need a real-time query, send it to Splunk. And if it's an information that is not that relevant, like debug information or sort of dummy message, hey, send it to Amazon S3, which is times cheaper. But of course, it doesn't provide you real-time search capabilities. So with this extension, what we are doing is allowing the following. Can you see the app properly here? OK. If you're familiar with the new configuration of Fluent Bit, can you read that, or it's too small? It's good. OK. So we have a pipeline, and then we have the inputs. Actually, we can see it here. So this is the input. Oops. This is the input from where the data is received from, right? I'm receiving data over HTTP. And I want to add some specific conditionals that says all the data that has been received. For example, we have this new block that is called routes. And route says, OK, the name of this route will be payment route. And the condition to follow here is like the context, meaning the body, the log body, will have a field that is equals name is service. the name is service, and if it's equal, must equal to this value, which is payment service. And here we have, of course, different options for the operations. If it's equal, if it's different, you can apply a regular expression. It's very configurable. And if it matches, it will route to the route 1. So basically what you say is like data that is here will flow to this output. Route 1 is here, the one that is blinking. Okay, this is a visual app to explain the concept, but this is not the UI of Fluent Bit, just in case you're asking. Okay, the same thing we can do now with a second route, right? So we can have a different type of service name, and you will see now that we are flowing the data. Oh, we have an animation problem. Okay, it's flowing to route number 2. Now, the name what you're saying, the destination in the boxes on the left are just standard output because that's how I'm going to use the demo, just to avoid to deploy Elastic Splunk in my laptop. Okay, and if for some reason the data does not match any of the conditions, you can define a special rule that says everything that didn't match, send it to a default place. Okay, so if you wanted to do something like this with the previous configuration, you had to create a lot of tags, matching rules, do tag rewrite for those who are familiar with that, and that was really expensive in computing time. So, and with this facilitation, it gets easier. Now, if we focus in the, I'm going to run this example now in the command line. Here are the outputs, the first block of the standard output. What I'm doing is sending to the standard output, and here's where I set the name. This is route 1. Basically, we're using names. If all of these matches, go to this place. And in addition, for the purpose to make it easier to consume information in this presentation, before sending the data to this route, I'm just upserting, meaning update or insert a key that is called route with the value or the name of the route that is being routed. So we know how the data was flowing. Okay, this is the same for route 2 at route 3 and the default one. You had to take a look at this. What is the value of the key route in this one? Okay, this is too small or not? Okay, I'm going to run, sorry? Oh, I cannot hear you, sorry. Okay, so I'm going to run my super command. I have a super command that runs curl, and curl we just consume a file that is called test_all_logs.json, which is this file. I'm going to pre-print it for you, which has a couple of records. And you will notice that the service might be different for each one. This is a payment service, this is checkout service, and so on. And in the configuration that we have here, which I didn't show you, this is the same thing that we have on the app. It's the same. So we have the routes, we have the conditions here. When service equals payment service, it will go to route 1. Okay, it's the same concept. On the left, we have the data in a structured way that says what are the values. On the right, we have what are the conditions and where that data will route from and to. Okay, so we just run Fluent Bit here. I'm going to send the data. You will see a lot of JSON on the right because we are using our terminal to send the data. So on the right, we have the output of Fluent Bit. Okay, this is a standard output. There's nothing fancy. However, you will notice that certain data was appended with a new route. So this is how the data was flowing to different places. This was to route 1. This was the default because user service doesn't have any rule, so it didn't match, so we use the default path for that. And same for checkout service that follow it to route 2. I would say that this is one of the foundations how we're going to migrate our users to do routing in the future, because if you think, who are you sending OpenTelemetry data? Are you using some OpenTelemetry or not? Oh, just one person. That's fine. We are preparing for the future. So when you send the data over OpenTelemetry, OpenTelemetry is not only around that, for example, the log record has metadata. It's also a bunch of records can share metadata. For example, a resource attribute, and all of those records has a shared metadata. So now with this new routing mechanism, you can say everything that is resource attribute, in the resource attribute has this key and this value, the whole content will be routed to a certain place. So you can do routing at a record level or at a group level. So as a summary, why this? Less computing time, less CPU. At some point, the configuration will be cleaner to see. But of course, we got a ton of feedback like, hey, let's work in a UI, because when you have 200 lines of YAML, it's really hard to consume and to get a mental model. And one of the other things about this routing mechanism is like, if some data was defined to be routed to a certain destination, and the destination point is down, and you restarted the agent, we can persist the routing logic in the file system until the agent restart and pick it up those records again, which give us a lot of flexibility and safety. In addition, now we have an extension for the syslog input collector. You know, we support many collectors as input plugins to consume data from different sources like HTTP, TEL, systemd. And we have one for syslog that is very powerful that works over TCP, UDP, Unix mode, Unix socket mode. And this extension is for the very old, not new, RFC 6587, which pretty much puts some length of the packet before the packet is sent. So you can know what is the length of the packet. And why do we care about this? Because a ton of firewalls in the world are using this format, and Fluent Bit is used for this as well. Another work in that is part of this release is in the security aspect on how we can consume specific certificates, right, that are not just public certificates for OpenSSL. Right? So if you're running on Windows, you can use Windows Certificate Managers for that. There are very custom environments or enterprise environments that says, hey, we manage our own certificates, and we use the Windows Cert Store or the internal services for that. And now Fluent Bit can take advantage of those. Who does sampling here or traces? So you're using OpenTelemetry. You didn't raise your hand. You were lying to me. OK, if you're doing tracing, it's because you're using OpenTracing, the very old way, or OpenTelemetry. OK? Fluent Bit, in addition to logs, support metrics and traces. Right? And in traces, this is from this year, not this release. It's for 4.0 that happened a few months ago. We implemented all the trace sampling capabilities, which means head sampling and tail sampling. The concept is really simple. Head sampling means like application and generating spans for a trace. And head sampling means I'm going to take some probabilistic decision based on the trace ID hash, and I'm going to drop 40% of them because I don't want to send everything. OK? That is head sampling. And it's pretty common and useful. The more complex one is what we call tail sampling. Tail sampling means like you set Fluent Bit or the OpenTelemetry collector in an aggregation mode, and you make all the nodes send all the spans, all the traces. And what tail does is to create a window of time to receive all these spans. And based on the conditional logic, it says if the spans match a certain condition, like this is the span name or the span has certain latency, I'm going to send the whole trace to my backend for analysis. Otherwise, I'm going to discard the data. And tail sampling is really expensive because you have to store the stuff in memory, you have to analyze the traces. And well, in the Fluent Bit world, we like to do the stuff in a very efficient way. And we always think that it's good for users to give choices. So you can do this with the OpenTelemetry collector, or you can do it today with Fluent Bit. OK. And for those who ask a lot, and usually when we are in this conference, we get a lot of questions because there's a lot of confusion around, hey, this is Fluent Bit, this is Prometheus, this is OpenTelemetry, how this fits together. And the story of Fluent Bit and OpenTelemetry, it's pretty much like OpenTelemetry is a standard for different telemetry signals. Today, the stable ones are logs, meters, and traces. And the way that OTel works is like it defines a schema. It means how the data is structured, right? If you take a look at the log in your syslog or from your application, hey, there's a structure, but there's no schema. Schema means like it's strict on this type of keys, this type of values. It works in that way. Okay, but OTel is very well defined, so developers and vendors can operate on top of the same schema and get the value of a standard. That's the vision of OTel. When the applications package this data in the schema, they use what we call the OTLP protocol, which is based on HTTP or HTTP2 in protobuf, and send this over the network. And in order to do that, the applications get instrumented with the OTel SDKs. So you take your application, you implement the OpenTelemetry SDK, so your application now can send OTel data. Now, how this correlates with Fluent Bit? Fluent Bit is able to work with the schemas. It's able to read and write OTLP. So you can set it on the middle, on the edge, and fully make it talk to OpenTelemetry instrumented applications. The vision that we have is like all users always, as I said, always needs to have a choice, right? And I think that if something is working for you, as usual, don't fix it. But if you're facing some OpenTelemetry, for example, performance bottlenecks or stuff like that, here's one option. And normally, users now deploy Fluent Bit in an aggregation mode, which means you have the remote endpoint sending data, and then Fluent Bit send the data out to your proper destination, which could be another collector or could be any type of OTLP endpoint. From a performance benchmark, this is old. This is kind of a 8-month-old benchmark that we did. And we did some other improvements, but they are not reflected this. We were benchmarking how different agents for log collection behaves under a certain condition. Hey, receiving data, adding just one key, and sending the data out. Okay? If you test something in benchmarking like read and write, there's not much computing happening. What is really important is like as soon as I get the data and I modify that information, what is the overload that I have in my system? Okay, so we found that in CPU usage, Fluent Bit was even beating Vector. I thought that Vector was faster on this. Vector is written in Rust. And the lesson here is that it doesn't matter the language that you write the tool. You can make any program slow if you don't use the right architecture patterns. OK, and we're almost to finish here. And I wanted to share that for every KubeCon, we have a signature T-shirt of Fluent Bit because we do a major release. Now we're releasing 4.2, and for Europe next year will be Fluent Bit 5. Okay, so these are the old versions, the version from this year. And if you see anybody of our team, like some maintainers that we have here, our community member down, Katie, that is right in the bottom, you can ask them for a new T-shirt that is for free. So. And yes, so that's all for now. And if you have any questions, I will be happy to answer those. Thank you. I think that there's a microphone.
Hi, thank you for the talk. I was wondering, like, Fluent Bit has started to look more like an OTel collector as well. Like, it can be a replacement for OTel collector. Am I right?
Yeah, the question is if Fluent Bit has started to become an OTel collector. Usually, in our world, we didn't have the word collector. Yeah. In our world, we used to be called aggregator. FluentD specifically has been an aggregator for more than 10 years, same as Fluent Bit. So yes, so if you ask me the deployment model, yes, you can see it on the edge, but also as a collector in the OTel concepts.
So follow-up question is, OTel collector now has OPAMP support, which is the Open Agent Management Protocol. Are you aware about that?
Yes, I heard about the protocol, and I think that the idea is good to have a protocol to standardize how you can manage a fleet of agents. One of the problems that I heard with OPAM,
OPAM.
and from one of the hotel maintainers is like all the interface of products that use that protocol is closed source by a vendor. So if there's no open solution,
Yeah.
it doesn't matter, you have to buy it. So I think I don't have a strong opinion unless we have something that all of us can use and consume. Because you have to go and buy a service to use that. And I think that this is where vendors try to push a little bit, right, to get the users. I believe that those type of solutions should be open, and the value should be created on top of that with enterprise features, but yeah.
So, but in your experience, is that a use case in the industry today? Do people want to need that protocol? Do they want to remotely control the configuration of their agents?
Yeah, there are two components. When you have, for example, in our previous company, in Calyptia, we implemented what we call fleet management. And fleet management, we have a plugin inside Fluent Bit for it that we use it in the product. Actually, the product is not open. That's why I'm complaining about the same. And the thing is, you know what is the problem? Is like, even if you take Fluent Bit and you take the hotel collector today, the remote configuration and hot reload is not like that. Actually, they pull the new configuration, they stop the process, and start a new one. And that takes seconds. So I think that the experience from remotely control one thing, I can do it with Terraform. Right? But if I'm not able to do really hot reload, I'm not getting the experience that I want. And I think that we're still far from that. Yeah, it's a good vision, but I think that there's no execution today on that.
Thank you.
Hi, Eduardo. So I'm building an observability pipeline, and my main issue is I have so many logs. Like, I have more logs than we should. And I do have like a bunch of processors, so a bunch of rules in my processing pipeline. And my concern is how like Fluent Bit handles the performance while I add more and more processors to my component. So that's my issue. I have too many telemetry data, very big scale, and my concern is like Fluent Bit might be throttled, and I'm not able to send all the telemetry data I should.
Got it. Are you processors, are filters or processors?
Filters, sorry.
Yeah. Let me check if I have some quick slide about that. The thing is that in the old way of Fluent Bit, in the way that it was working, it was using like what we call, it was a single thread, and filters were running together with the main event loop. Okay?
Yeah.
This is it. Okay? So with a new multi-thread architecture, what we did is like we allow input plugins to run in a separate thread. That was step one from a development perspective. And now we allow to run filters in a new concept that is called processors. And processors are attached to the input plugin. And if the input plugin is running in a separate thread, you're using likely a different CPU core.
Right.
And that's a way to scale using multi-threading. I don't know if I have a better image for that. No, I think that will be. Because what happens is that before we only have one thread, and that's where the contention happens. That's what you're saying now. That's your case, right? But we move in a different way. We separate in threads, and we try to split the processing units per context and not have everything in the main thread.
All right, yeah. Do you have like a comparison between, for example, you showed us a comparison between like Vector, OpenTelemetry, Fluent and Fluent Bit. Do you have any graphics at all that show the evolution of the resource consumption while I add more and more filters? Like, so if you have 10 filters, I have like this performance. If I have 100, I have this one. Just for me to like to be able to compare the performance between all the other options I have.
Yeah, that's a good question. It's like how to benchmark these scenarios, right? And I think to be really honest, your results won't be my results. Your use case, your workload is totally different. The processing that you have and the one that I need, they're different. So my suggestion is just do your own benchmarks. get a guide from what we publish, but Vector is always a winner. Fluent Bit is always the winner, right? But it's based on our view from how we can improve this. So my invitation is to do it on your own. Yeah.
Thank you.
You're welcome.
Hey.
Hey.
So from a workstation perspective, not so much for Kubernetes, but we run a mixed environment of Windows and Linux. And for our metrics, we use Telegraph. And for logs, we're using NXLog. I don't know how much longer we're going to be using NXLog. And I thought it was an opportunity to start looking at Fluent Bit to combine those two together. One of the challenges I'm seeing, though, is that Fluent Bit doesn't support Windows as much. Do you see anything about enhancing that on your roadmap or anything like that?
Yeah. So what I have seen, we have been helping for a couple of years, is like cloud providers and financial institutions like JP Morgan, Visa, Morgan Stanley, all of them has one pattern. They will always wanted to have a unified strategy for metrics collection, right? And majority of them unified already in Fluent Bit. And we are aware about other use cases, like for example, Bank of Australia, yeah, they use Fluent Bit, and majority of their fleets are Windows. So, and Fluent Bit, yeah, is fully supporting Windows.
What about for like deep event log?
Sorry?
Like what about event logs on Windows where it's like deep into the XML? I mean, do you?
Yeah, we can process those as well.
Oh, okay.
And we have one of our Windows maintainers here. Hiroshi is there, so he can help you with that as well.
Yeah, thank you.
You're welcome.
Does Fluent Bit now support with OTLP format? Are you able to amend any of the attributes, or are you relying on the upstream, the providers, to give you all the attributes and to make your routing decisions?
Which metadata, sorry? Which one?
I was asking if you can modify OTLP.
Oh, yeah.
So the attributes that come in, you mentioned routing, which I've been waiting for basically OTLP support on the other side. Because
yeah, we have a processor that is called content modifier. A content modifier can operate in different contexts for traces and for logs. And we have some kind of shortcuts for OTel, so you can tell it where to operate.
Okay, resource or log. Okay. And
Yeah.
one more question, if I
Yeah.
can. AWS FireLens. Are you working with them on the availability of Fluent Bit 4.2? Is that coming? Because I think what they have right now is
With FireLens,
Sorry?
with AWS?
With FireLens, yeah.
Yeah, so we work with the AWS team. Actually, as a project maintenance, we work with maintainers from AWS, Microsoft, Oracle, different companies. So yeah, if you have a more specific AWS question, because they maintain their plugins into the ecosystem,
Gotcha.
happy to forward it.
Thank you.
Thank you.
Hey, I was gonna ask basically a very narrow scope technical question. I was struggling, well, though I'm not using the 4th version, I'm using the 3.2. I have been struggling a couple of times and like unsuccessfully modifying some data, some label when it's nested into a group. When I'm parsing a log, for example, Kubernetes log, and that comes nested in the Kubernetes section, is it possible to drop or modify a single value when it's nested without pulling it, modifying, or dropping it and nesting the rest of the things back in the section?
Okay, so the question is, if like you have a structure with different levels, depth levels, so if you can remove certain key from here. Yes,
Yep.
it's possible. We have with content modifier, you can do it. And the way to express where that key is what we call a record accessor. Thanks God, Wi-Fi is working today. So
Yeah.
with the record accessor, you can define how to enter in certain levels for objects or arrays.
All right. Thank you. We'll give
Welcome.
it a try. Thank you.
Okay, thank you so much. So we will be outside here in case you want to talk more, or grab your copy of the Fluent Bit book or t-shirt. Thank you.